Hello students, today's topic is inference theory of predicate calculus. That means rules of inferences for quantified statements. Okay. Rules of inferences. Rules of inference for quantified statements. To understand the theory of predicate calculus, we have to know these rules. First one, rule US. It is universal instantiation or universal specification. Okay. That is for all x, p of x. Therefore, p of c for any c. Okay, this is universal specification. Okay, also known as rule US. Next, rule UZ. That is universal generalization. Universal generalization. P of c, therefore for all x, p of x, p of c for any arbitrary c. P of c for any arbitrary c, therefore for all x, p of x. This is rule UZ. Next rule, rule ES. That is existential instantiation or existential specification. Okay, that is there exists x, p of x, therefore p of c for some element c. Okay, this is rule ES. Next rule, rule EZ. That is existential generalization. Okay, that is P of C for some element C. P of C for some element C. Therefore, there exists x, p of x. This is rule EZ. Okay. There are some equivalence formulas on quantified statements. See this. First one, there exists x, a of x or b of x is equivalent to there exists x, a of x or there exists x, b of x. Second one, for all x, a of x and b of x is equivalent to for all x, a of x and for all x, b of x. Third one, negation of there exists x, a of x, that is equivalent to for all x, negation of a of x. Next, negation of for all x, a of x, that is equivalent to there exists x, negation of a of x. The next one, for all x, a or b of x is equivalent to a or for all x, b of x. Sixth one, there exists x, a and b of x is equivalent to a and there exists x, b of x. Seventh one, for all x, a of x implies b is equivalent to there exists x, a of x implies b. Next, eighth one, there exists x, a of x implies b is equivalent to for all x, a of x implies b. Next one, there exists x, a of x implies b of x is equivalent to for all x, a of x implies there exists x, b of x. The tenth one, there exists x, a of x implies for all x, b of x is equivalent to for all x, a of x implies b of x. These are some equivalence formulas on quantified statements. Next problem. Verify the validity of the following argument. Verify the validity of the following argument. All men are mortal. All men are mortal. Socrates is a man. Socrates is a man. Therefore, Socrates is mortal. Okay. All men are mortal. Socrates is a man. Therefore, Socrates is mortal. Okay. Or this can also be given as show that for all x, h of x implies m of x and h of s imply m of s. Okay, this can also be given like this. Okay, now the conclusion is Socrates is mortal. Okay, see the solution. Let us represent the statements as follows. Let h of x, x is a man. H of x represents the statement x is a man. M of x, x is mortal. S stands for Socrates. S means Socrates here. Okay. Then I have to show that for all x, h of x implies m of x. This means all men are mortal. Okay, and h of s means Socrates is a man, imply m of s. That means Socrates is mortal. This is our conclusion. Okay. Step reason. Step 1. For all x, h of x implies m of x. This is rule P. Since this is in given premises, rule P. Okay. See the next step. H of s implies m of s. Since for all x, h of x implies m of x, and hence h of s implies m of s by rule US. Okay, rule US using 1. Okay. Next step. H of s. H of s is in given premises. Okay, that is rule P. Okay. See this. Observe the second and third steps. H of s implies m of s, h of s. From this, by modus ponens, you can conclude m of s. Rule T. Using 2 and 3 by modus ponens. That means P implies Q is equivalent to Q. This is modus ponens. Okay. See this. Fourth step is m of s. This is required conclusion. Okay. That means Socrates is mortal. Okay. It is Socrates is mortal. And hence the result. Okay. See the next problem. Verify the validity. Verify the validity of the following argument. Of the following argument. Every living thing is a plant or animal. Every living thing is a plant or animal. Joyce goldfish is alive. Joyce goldfish is alive and it is not a plant. It is not a plant. All animals have hearts. All animals have hearts. Therefore, Joyce goldfish has a heart. Has a heart. This is the given argument. You have to verify the validity of this argument. See this. Every living thing is a plant or animal. Joyce goldfish is alive and it is not a plant. All animals have hearts. Therefore, Joyce goldfish has a heart. This is our conclusion. Joyce goldfish has a heart. Okay. See the solution. Let us assume that the universe of discourse is all living things. Universe of discourse is all living things. Okay. Let us represent the statements as follows. Let P of X is the statement X is a plant. E of X, X is an animal. H of X, X has a heart. Next, F, Joyce goldfish. Joyce goldfish. Then the given argument is of the form. Given argument is of the form for all x, P of X or A of X. This means every living thing is a plant or animal. Okay. Negation of P of F. This means Joyce goldfish is not a plant. Okay. Next, for all x, A of X implies H of X. All animals have hearts. This means, okay, imply, what is the conclusion? Joyce goldfish has a heart. That means imply H of F. H of F means Joyce goldfish has a heart. This is our conclusion. Step, reason. See the first step. For all x, P of X or A of X. This is in given premises. That's why the reason is rule P. Rule P. Okay. Next. From this we have P of F or A of F. Okay. By rule US. What is rule US? For all x, P of X. Therefore, P of C for any C. Okay. We have for all x, P of X or A of X. From this, P of F or A of F. Rule US using 1. Okay. See this. You know that P implies Q is equivalent to negation P or Q. From that, you can write this negation P of F implies A of F. Okay. Rule T. Since we are using a formula, rule T using 2, and the reason is P implies Q is equivalent to negation P or Q, and hence negation P of F implies A of F is equivalent to P of F or A of F. Okay. See the next step. Negation of P of F. This is in given premises. That's why rule P. Okay. See the third and fourth steps. Negation P of F implies A of F. Negation P of F implies A of F. This is by modus ponens. Rule T. Using 3 and 4. Using 3 and 4. And Modest ponens means P implies Q, imply Q. Negation of P of F, negation of P of F implies E of F, implies E of F by modest ponens. Okay. See the next step. For all x, A of x implies H of x. This is in given premises. Hence, this is rule P. Rule P. Okay. Next. See the next step. You can write A of f implies H of f. By rule yes. If we have for all x P of x, then P of c for any c. Okay. That is rule yes. Okay. Rule US using 6. Understand? For all x P of x, therefore P of c for any c. Okay. That is rule US. See the next step. Observe 5th and 7th steps. 5th one, A of f. 7th one, A of f implies H of f. By modest ponens, P implies Q, imply Q. Okay. That's why using 5 and 7, we get H of f. Reason, rule T using 5 and 7. And the reason is P implies Q, imply Q. That is modest ponens. Okay. Now this is our conclusion, H of f. Okay. That means Joyce goldfish has a heart. Has a heart. Okay. This is our conclusion, H of f. Okay. And hence the result. Next problem. Show that there exists x m of x follows logically from the premises for all x H of x implies m of x and there exists x H of x. Okay, our conclusion is there exists x m of x. Okay, see the solution. Step reason. Step 1. There exists x H of x. Since this is in given premises, the reason is rule P. Okay, from this H of y, you know that existential specification rule is there exists x P of x, therefore P of c for some element c. Okay, here there exists x H of x, therefore H of y for some element y. This is rule ES using 1. Okay, next, for all x H of x implies m of x. For all x H of x implies m of x. This is in given premises. That's why rule P. Next, from this we have H of y implies m of y. This is rule US. You know that rule US is for all x P of x. Therefore P of c for any c. Now here for all x H of x implies m of x. Therefore H of y implies m of y. This is rule US using 3. Using 3. See the next step. Observe second and fourth steps. Second is H of y and fourth one is H of y implies m of y. From this we get m of y by modest ponens rule. Okay. Reason is rule T using 2 and 4. Using 2 and 4 and P implies Q, imply Q. This is modest ponens. Okay. See the next step. We have m of y. Therefore, there exists x m of x. Okay. By rule easy. Okay. Rule easy. What is rule easy? P of c for some element c. Therefore, there exists x P of x. Here, m of y for some y. Therefore, there exists x m of x by rule easy using 5. And this is our conclusion. There exists x, m of x, and hence the result. Okay. Okay, students. Thank you so much for watching. See you in the next video.